Okay, this is a repeat of what I will have shown you in the lecture, and this is a project which, as I will have said, is sitting on my desk this week, and I have looked at a number of kind of what I suppose high-level environmental suggestions for the site, and we've arrived at a massing such as this, and I will have explained to you why I would propose this massing rather than the one that we started with. Okay, so I just want to quickly show you again a couple of those techniques that we use just to modify this. From scratch, when you open the model that you'll see should look like this, and you'll see a couple of things from the start. I've just changed the color of that block, which we can't touch, and I've made some of the elements transparent, which are the glass elements, so you don't need to worry about that. To rotate as I'm doing, it's kind of your mouse will do everything for you. Right click is to pan, and you can zoom in and out with your wheel, and then you can do everything really like that. Okay, so the first thing we wanted to do was to understand how this massing affects a particular place. So if I zoom in using my middle wheel, you'll see that I have put 3 windows there. So we're just going to look at this scheme with respect to those 3 windows. You'll probably remember I will have shown you that the program Ecotect has 2 tabs. One is a visualize tab in which you do most of the visual work, not the actual modeling work. And the modeling work is done in the second tab, which is 3D Editor. So we'll do a lot of work in 3D Editor. Before we do that, I'll just show you a quick thing which is going to help you. I have already loaded a climate in here, which is Dublin. You don't need to do that, but just it's worth noting that this is going to be specific for Dublin. That's important because when I press this button here is under Shadow Settings. When I click on Display Daily Sun Path, you'll see now that is the path of the sun. When is the path? It's on April 1st and it's in Dublin. And then if I click on Display Shadows, then it will also display the shadows on that day, not on any day, on that day. So we can see, if I move the sun around, we can see what that does, which is fine, but not terribly useful in terms of evolving the massing. So we can understand the relationship of the sun to this window a few ways. I suppose the most obvious way, other than looking at the window, moving the sun and seeing if the sun ever passes it, which it appears not to. Another way we can do it is to view that window from the position of the sun. It's a bit weird, but I'll show you what it gives us when we do it. So that's that button there. This shows me what I would see if I were the sun. And again, if I move the time along here, it gives me an axonometric projection, the relationship between the sun and the windows. It's kind of handy, and obviously if I change it to a different month, let's say December 21st, when the sun is at its lowest, and if I repeat that exercise, I can see that the sun will see barely anything of those windows. I would expect that at one brief instant, sometime around 1:30, one of the windows might just get a little glance of the sun. So that's one way to do it, but actually it's not a great way because it's hard for me to really be precise. The better way in which we do it, when I've unclicked that, so I'm back in perspective mode, is to actually understand the relationship between the sun and the window by looking at the window. So the way we do that is I'm going to go into 3D Editor for the first time. Now when I go into 3D Editor, things might look a bit crazy, but I'm going to zoom out, see what's going on. It's all a wireframe model, and I'm going to turn off the shadows so I can actually see what's going on. And I'm going to zoom back into one of these windows. Now the windows, as you can see here, comprise reveals, so I've given them depth, which is kind of important. And I'm going to pick one of the panes of glass. Now the thing about Ecotect, it's a little annoying, sometimes it doesn't quite know what to select. So really what you do is select something that's close to the thing you want to select and then press spacebar. Eventually it'll keep toggling through the things that you might want and eventually get to the one you do want, which is, in our case, this window. Once I've got that window, I just have to check one thing, which is what it understands is inside and outside. That's important for Ecotech because it's a program very much about interfaces between inside and outside. So I'm just going to press Control W. Oh, that's not what I want. Control Q. Sorry, Control Q. When I do Control Q, it shows me an arrow, which we call a normal. Normals always must face outside. So this normal does not, so it's wrong. So I have to reverse the arrow, that's Control R. Now I have a normal that faces outward, which is what I want. Okay, now with that arrow facing outward, I want to ask myself the question between the relationship of the sun and the wind on this window. What is it? Very simple. I go to Calculate and I do Sun Path Diagram, and I get this. Now I will have explained this to you again, what this is, in the lecture, but just to remind you, this is you lying on your back looking to the top of the sky, and each of these, this is the point right above your head at the top of the sky. This outside side of the circle is the horizon, and the blue lines represent the path of the sun as it tracks through the sky. In the case of Ireland, it tracks very low through the sky, just reaching about 12 degrees in winter. So you know it's 12 because these concentric circles tell you how high it is. There's 80, 70, 60, 50, 40, 30, 20, and here we are at about 13 degrees. Or in summer, when I'm up here, how high is in the sky? Well, it's 90, 80, 70, 60, just under 68 degrees. So we can understand where the sun is in the sky using this diagram. It's called a stereographic projection. We can also see when things are in the way. So each of these dark patches represent an obstruction to the sun. So now I can see, what's that gap there? That gap is exactly the gap that in the other projection I could see the sun was shining in through the window. And there it is. There's the gap. I know it's 1:30 because there's 1 o'clock, 2 o'clock. And on December, which is here, I see that the buildings aren't shadowing the path of the sun between those 2 hours. That's kind of handy because now I can understand in one diagram every moment that this window will see the sun rather than doing it vice versa. Now, the reason I want to show you that is because now we can start to improve this situation. This isn't great for that window, so let's make it a little better. Okay, the first thing I'm going to do is I'm going to draw a line at the bottom of the window. I'm going to use this line tool here. I'm going to click there, and I click there, and then just click to finish it. The reason I draw that line is because what I want to do is I want to extrude a plane toward the sun. I'm going to pick a day rather arbitrarily. The day I'm picking is February 21st. So that's kind of, it's not the winter solstice, but it's early enough in the year. And I want to make sure that this sun will receive, that this window will receive sun on that day. So what I'm going to do is I'm going to extrude this line towards the position of the sun. So if I go back to visualize, on February 21st I can see the shadows there, and if I do what I did before and I view from the position of the sun, I can see that those windows will receive some, if not a lot, solar access. But again, if I do what I did before, pick the window, press spacebar to get the window, and go display, calculate sun path diagram, and I pick February 21st. I would expect, solar access again, done half 1 to 2, so, and then a little bit there, not an awful lot. So what I'm going to do is I'm going to basically extrude a line. I've drawn the line already, I showed you how to do that, and I'm going to extrude it, making sure that the time is set to 12 and the date is set to the 21st of February as I had before. The tool to extrude a line is under Shading Shadows, Project Selected Objects, and extrude toward sun. When I extrude it, it's a bit easier to look at it and visualize, and make sure I'm looking at perspective. I end up with this rather long, transparent object cutting through my buildings, and it's good that it's cutting through the buildings because I'm going to use that cut to chamfer the buildings. And that, remember, that is the line between the position of the sun and the position of the window. Okay, so all I need to do at this point now is slice the buildings with respect to that. I'm just going to retrace that shape just for Ecotec to understand that. So I'm going to use this plane tool here, very simply. I'm just going to click, click, and then I'll just go down there and click, click. If you want to close the shape in Ecotec, you do need to press escape. That's just how it is. So I've just retraced that, same shape, just retraced. So I need a solid object to do what I'm doing next. And that is to define it as a cutting plane. To do that, Control Q. Control Q, again, one of those pointy arrows we saw earlier. In this case, the pointy arrow needs to face upward, and you'll see why. And that is basically the clipping plane which I'm going to use to cut these buildings. And I'm going to rotate around so I see the buildings that I want to cut. I'm going to select them there, just those buildings. I don't want to cut the existing one. I'm going to press Control W, which is trimming, and it'll say do you want to trim, and I say yes. And now what I've got is, I'm going to visualize again, is a very different relationship between that window and those buildings. They've been cut quite dramatically along the line I defined. So let's get rid of that line, select delete, and let's do what we did before and look at that one window. Again, spacebar until the window I want. Let's go calculate some path diagram as we did before. Well, now we can see that things are a lot different. We can now take our 21st line and we see that actually we will have solar access all through that month. So this window now will only be disadvantaged in the depths of winter, January, early February. But come mid-February, we've guaranteed solar access. So we basically, we can say measurably, we've improved situation. Okay, so that puts us to a very simple way in which you can relate solar geometry to building geometry, and obviously the building's going to look like this, but it's a start to start thinking of that. The other thing I want to show you is how you can then understand how that what the condition in that room is likely to be. Well, a handy way to see inside the room is to use this eye here and to go down a little bit to no, what do I want to do? Oh yes, I'll click on the eye to this section plane. There's a cutaway section. When I click the cutaway section, it gives me this section across which I can move according to what I want to see. So I'm just going to move that right until I can see inside my building. I've made a little room there just so you can see there's the windows, floor, ceiling. And I just want to ask a very simple question, is given a couple of things I did in this building, which I will have told you about making sure the plan depth wasn't too deep so it has this relationship to an atrium, what might I expect in terms of daylighting in that space? Well, a very good way we can do that is, again, we can measure it, we can see what it is. So I'm going to go back to 3D Editor, and I'm going to turn on this blue square here. This is what we call an analysis grid. I've set it up already for you, so you don't need to do anything, but it is fairly easy to set up a different one in a different place. What this is going to do is it's going to measure daylighting levels, and we know the daylighting levels are going to be a function of how many windows. We've got 3 on this side and 3 towards the atrium, but also a function of what's in front of those windows. And as we know, we've already chopped buildings, so these windows will have a greater relationship to the sky. So the way Ecotec works this out is very simply with an algorithm in terms of daylighting. So I'm going to use that algorithm as follows. I'm just going to do this calculate lighting analysis. Those are things we can do. I'm only going to do one, which is the natural lighting levels. I don't have any lights on. I just want to know what the light is. Can I make it better? I'm going to go through this. You just need to follow what I'm doing. It's over the analysis grid. I'm going to keep it medium because I don't want it to be here all day. We tend to simulate things under worst case conditions. This overcast sky is what we would do. Window cleanliness, I'm going to just pick average. You can just use regulatory compliance, that's fine there. And we get to this summary screen. That is all the things you've already answered. The only thing I want you to make sure is display test points is on. And you'll see why. I'm going to press OK, and what you're going to see is these green dots spraying around. Each of those dots really represents a calculation, and the calculation is trying to understand how light from the sky is getting into this room, and on the way it has to bounce off many things, including the buildings opposite, including the ground opposite. It has to pass through the windows, which have a certain transparency. It also then has to bounce around the room based on the reflectance of the walls and the floors and the ceiling. So what Architect is doing is it's trying to understand all those different interreflections and give you a number for the amount of light at each point. And it does this, as I say, through an algorithm which it represents graphically with these green dots. And what it's doing, as you can see, is it's getting working its way across the grid, and eventually it will finish. And when it finishes, you will be left with something like this, which is again a graphic representation of lighting in this room. If we view it in the plan level, I'm going to press F5 for a plan. You might see it better if I go up here. I can do a few things. I can turn on the contour lines. It says, I suppose, what you would expect to be the case, that the light is greater by the windows than it is the middle, and also the light is greater facing the street than it is the atrium. But the key thing which is useful, and I find it useful, I'll just go back to 3D again. In fact, I can see this also in the visualize mode, which is kind of handy. So I'm just going to go there. I'll turn on off the 3D. What's handy is it allows us to put a number against this. To see the number, I do have to be in 3D editor, and it shows me there that there's over 4.8% daylight factor in this space. And that's very good. Anything over 2% is more than enough. But if it were too low, if it were too dark, well, I would have some clear options in front of me as to how to make it better. Either increasing reflectance or window area, or another architectural strategy which I might choose to employ. But the point is that it's establishing what the existing situation is allows me to make those changes and quantify the effect of those changes. Okay, this program can do many more things, but I'm not going to show you them because I think all I wanted to show you was two very simple things relating to sunlight and to daylight. So hopefully that gives you a taster, and then you can take it forward from there.